Okay, this is the second half of worksheet 1A, where we'll pick up with problem number 4. And the domain here, and again, assuming that since they are going off the grid with no filled in dots at the end, those are assumed to be arrows that are going on forever. So we're going to start out with the domain as being all real numbers. The range is going to go as low as 1, but it goes from 1 to infinity, and that is with a bracket. There are no x-intercepts, and y-intercept is at 5. The maximum is undefined, and the minimum is going to be 1. Right. This graph, when we start looking at increasing and decreasing and such, we want to look at where it takes key turns, and then infinity on this end. So it is decreasing from negative infinity down to where x is 2. And then from 2, it picks up and increases to positive infinity. The whole thing is positive, and there are no breaks in it. There's nothing negative because there's nothing below the x-axis. And the end behavior as x approaches negative infinity, y is going up. As x is approaching positive infinity, y is still going up. All right, new graph. The domain, well, and again, these are arrows going on forever. Domain is all real numbers. The range is going to be all real numbers. The x-intercept, we're going to have to get clever about this because, and I'm going to use this and this. And we're going to do a little bit of this. All right, we know, as a matter of fact, we can even back up here and start it there. That is negative 4 and 6. That is 0 and 5. And that is 4 and 4. Now I want you to notice that each time x moves up by 4, y is dropping by 1. So I can project ahead. The next 4 is going to drop 1. Another 4, drop 1. Another 4, drop 1. And another 4, drop 1. Now that is your x-intercept. So we were able to calculate where the x-intercept was going to go. Because it was not an unreasonable jump of doing a little rise over run there. All right, the x-intercept is at 0, 5. It's not going to have a maximum because it keeps going up forever. It's not going to have a minimum because it keeps going down forever. And the increasing and decreasing gets interesting. It is never increasing. It is always decreasing. And we said earlier that, when it reached the point of 20 and 0, I don't want to do that there. When it reached the point of 20 and 0, that's when it crosses the x-axis. So it's going to stay positive all the way up through that point. It's going to stay positive from negative infinity all the way up to 20. Once it touches 20, that is where y is 0, and it is neither positive nor negative. And the negative picks up from 20 and goes on toward positive infinity. Because you've got negative infinity, you've got 20, well, I can't write over there, 20, and then you've got infinity somewhere further down. So my endpoint behavior as x approaches negative infinity on the left side, y is going up. As x is approaching positive infinity on the right, y is going down. Okay. And the last one, we have an exponential curve. And we understand that the nature of an exponential curve is that it will never touch the x-axis. It will continue to approach where y is 0, but it will never quite reach there. So my domain does go the full length, left to right. My range starts at 0 and goes toward positive infinity. Now, does 0 get a bracket or a parenthesis? Remember, it approaches 0, but it never touches it. So it gets a parenthesis. That also is going to mean that there are no x-intercepts. There is one y-intercept. There's not a maximum because it goes up forever. And the minimum, I'm going to write it like this. Because we can't say that 0 is a minimum because it never touches 0. But this is kind of like an open circle. We can say that it gets as close to 0 as you think possible, but it will never actually touch 0. Increasing and decreasing. Well, it is all increasing the whole way. There's not a bit of it that's decreasing. There's not a bit of it that's negative, and the whole thing is positive. As the end behavior, a slight tweak here, as x approaches negative infinity, y is approaching not infinity, but it's approaching 0. And now going out the other end, as x approaches positive infinity on the right, y is going up forever. And that should do it for 4, 5, and 6 here at Worksheet 1A.